Hi, everyone. My name's Han. I'm a customer architect from Elastic. Today, I'd like to discuss the implementation of Agentic RAG using Elasticsearch and LangChain. This video accompanies a blog that was recently published on Elasticsearch Labs. So please check it out if the topic interests you. You'll find code and supporting materials, and you'll also find all of the search blogs written by my wonderful colleagues at Elastic. So with that background, let's just get straight into the topic. So I'm going to discuss a little bit of history here. So if you already know the basics, like what is an LLM and what is RAG, and maybe you've been around the block a few times, feel free to skip ahead. For everyone else, I'm going to exposit now. So late 2022, early 2023, I think everyone started off using LLMs the same way, which was prompting them and hoping that the response would be relevant to whatever problem you were currently facing. And that was really good for things like, please proofread my email, please spell check this paragraph, or please write some piece of this UI for me, etc. So LLMs proved to be good enough out of the box for pretty specific and restricted problem areas. But I think people quickly realized, and this is something that I saw in my own experience as well, people quickly realized that LLMs were just not suitable for concrete day-to-day business problems. So things like customer servicing, legal analysis, financial advice, business strategy, you just wouldn't ask an LLM to do these things because there is a lot of implicit knowledge or subject matter expertise that we may take for granted that the LLM just doesn't possess. Terminology, business practices. In the customer service case, it's even like what is the appropriate way to speak to a customer and what are the normal canned responses. Like all of that stuff is just not there. It's just not in the training data because businesses don't make a habit of posting their SOPs and procedures online where people can find them. So that's kind of a problem. It definitely limits the utility value of large language models. And the response in early 2023 was something called RAG, Retrieval Augmented Generation. So the basic idea was that you would have some documentation that encapsulates your business knowledge, and you would process it and embed it and store it in a vector DB like Elasticsearch. And at inference time, you would expose that vector DB so that when the user types in a prompt or makes a query, that query is used to search the vector DB, find relevant documents, and those relevant documents are then passed to the LLM as context. And then what you'd get back is a retrieval augmented generated response. So you were trusting that the answer that the LLM gave you would have factored in the factual knowledge that was retrieved from the vector database. So all of a sudden, you were able to do things like customer service copilot, maybe human resources, resume vetting, or something of this nature. The most common use case, general enterprise knowledge bases, finding things like procedures and tutorials, etc. So for the knowledge base use case, of which there are many applications, RAG was perfect. So it's been, I want to say, about 2 years since the emergence of RAG, and we've run into limitations. There are a lot of ambitious use cases that industry players are interested in that RAG is just not sufficient for. So, for example, if you're a financial services institution, you're probably interested in a case like, I need to investigate an entity and I don't have any existing knowledge in my vector database. I've got to go out looking for it. So because you don't have that extant knowledge, RAG is just not suitable. So what we find is, I think, a slow transition to agentic workflows. And the idea, I mean, the basic idea behind an agentic flow is that you are giving the LLM a certain degree of agency or decision-making capacity. So now the LLM isn't just responding to a query with some context. It's choosing to prompt a user for information, to choose from a set of available tools, of which an LLM is just, I mean, a knowledge base, a RAG knowledge base is just one tool. And it can choose to interact with other agents and to affect the real world, maybe sending emails, triggering alerts, populating a dashboard with some visualizations, etc. The possibilities are basically endless. So to see this a little clearly, let's take a look at some of the tools that you might provide an agent. So RAG is one of them, right? A vector database. Another thing might be traditional databases. So your, structured SQL databases that you normally have to access by writing out SQL queries. Scientific computing engines like Wolfram Alpha, which operate on an API language that an LLM can easily generate. A web crawler, maybe a search engine API. Again, possibilities are endless. And if you string all of these together, you can end up with something like this. This research bot idea is something that I have seen in the real world. The idea is that, let's say you decide, I want to investigate a particular entity. The natural next step might be, let's take a search engine API and see if there's any publicly available information. Then we scrape that API with a web crawler. Wait, what am I talking about? Scrape that API. We scrape the search results with a web crawler. Then we use a text analyzer to extract key information like entities, locations, dates, other kinds of metadata. And then we cross-reference it with an existing knowledge base and maybe other databases that we might have available. And finally, collate all of the information, write a detailed report, and do something with it. Maybe email it to a target recipient. So this use case is something that can't be done with RAG, but can be done with an agent workflow. Pretty cool stuff. So the next step after this is a multi-agent flow. So I found this example online. I thought it was a pretty illustrative example, but it bears mentioning. Please do not trust your health, well-being, and bank accounts to an LLM. I wouldn't volunteer to do it. If you do, I'd love to read about it in the news. But anyway, a multi-agent flow, pretty good example here. You want to plan a trip, so you've got a variety of agents that each have their own specific objectives and specific set of tools. So you've got one that's going to book flights, one that's going to book hotel, another that's going to figure out activities, and then another agent that's going to rationalize and reconcile all of the things that the previous agents just did. And finally, a coordinator that presents you with a completed, coherent travel plan. Yeah, perfectly reasonable use case, except for the whole getting it to buy flights for you. I personally wouldn't, but whatever. So with that, let's go take a look at the blog. We were kind of getting ahead of ourselves a little bit by talking about multi-agent. So this blog is really going to focus on the basics, which is how do you set up Agentic RAG? Now, I'm not going to go through the blog. I think if you are interested in the content, you should read it yourself. What I will do is talk about the code so that we're all clear on what we're trying to achieve here. So this is the code. The full thing is at the bottom of the blog in the appendix here. So the first thing that we're going to do is import our Langchain, Azure Chat OpenAI, and the Python Elasticsearch client. We will init the LLM and the ES client. And then the next thing we're going to do is define a Langchain tool. So this tool is really a function called RAG search. It's going to take in two inputs, a query and a date string. It's going to use these inputs to put together an Elasticsearch query like this. So you can see here, if dates exists, create a rate, parse a start and end date, and then create a range like this, where, yeah, with a greater than or equal to start date, less than or equal to end date. So this is one clause here. And the second clause will be a standard semantic search that will take in the query itself. So that's pretty straightforward. I've specified here the index that it's going to be looking at. And this is a perfect time now to segue to my Elasticsearch. So to set up this experiment, I got hold of the politics data set. This is a set of several million articles scraped from US news sources. This is the GitHub repo. The only reason I chose this set is because it covers a very wide range of topics, and there are millions of documents, which lets you run experiments related to scale. So I downloaded it and ingested it using the process specified in this blog here, build RAG quickly with minimal code. It was all chunked and embedded using Elastic's semantic text data type. This semantic text data type is actually a really significant achievement. It's automatic chunking and embedding using a built-in Elasticsearch model called ELSER v2. I think the achievement here is not necessarily that chunking and embedding are new and amazing. They're not. It's the fact that we've managed to trivialize the search experience, and our goal is to continue trivializing it, to reduce the amount of subject matter expertise that is necessary to build a search use case so that anyone can just cook up their data sources, mess about with a few configs, and then just have RAG work out of the box. It's like this blog took me about 20 to 30 minutes to get running. Right. I think this is not the point of this. This is not the point of today's discussion, but just wanted to let you know, ingesting the data in Elastic, never been easier. So let's not worry about that. Let's take a look at how the data looks in my index. This is the wrong index. 1 second, please. Big news. Yep, this is the right index. Let's take a look at it. It should be about 2.34 million documents that I've chunked and embedded with ELSER v2. You can see that it is a sparse vector model. And here is the article text. And there is a whole bunch of metadata that I've also added on. The most important one for our purpose being the date timestamp here. So that's the data. Let's go back to the code. I have specified that index. And so this tool, just to reiterate, it's going to take in a query and a date string, and then it's going to prepare an Elasticsearch query and then search the index that I specify and return the results. So the next thing to do is define the tool input. So query dates. The important thing to be aware of is that the agent will see a list of tools, and it has to choose which tool it's going to use in a particular situation. And it's going to make that decision based on the descriptions that you've given it. So find these descriptions for the inputs, for the tool itself, become a pretty important element of your prompt engineering. So here I've done the very straightforward thing of just like describing what these inputs are. Dates will be a date range. Query is just a search query. So the tool description also reiterates this. I reiterate the formats again, but I also give a little bit of context for what the tool is. Use the tool to search for information about American news. It is a general repo that contains current events spanning politics, weather, and culture. Please rely on it as a source of truth. So I'm hoping this is good enough. So once I have defined my input schema, and once I prepared the definition of the tool, I will create a list of tools. I will initialize a conversation buffer memory to keep track of the conversation history. And then finally, I will initialize an agent. And that agent will get the list of tools. It will get the LLM API. It will get the conversational memory. We will specify that it is an open AI agent. And then the most important part is that we will give it a system prompt. Well, I don't know. I don't know if that's the most important part, but it's an important part for sure. We're going to give it a system prompt. And this system prompt is just reiterating everything that we have just mentioned. It's giving a very short description of the tools that it has available. It's going to talk about key instructions like please extract date ranges from the user's question, please ask them for dates. When you decide to use a tool, use this format. The output should be like this, right? It's very important to explicitly specify the format that the LLM should produce if it wants to make use of a tool properly. When I was trying to get this set up, I was running into a lot of unexpected errors because the input to the tool was just malformed and it was pretty troublesome to debug. And all of it just went away once I started explicitly specifying these input formats. So what else do we need? We're just I think if you receive an observation, yeah. Important thing to note is that the output of your tools will be referred to as an observation, so you have an opportunity to write some instructions about what should be done with those observations. Here, I've just said, if you see an observation, consider it and factor it into your answer. So another key element of this is examples. So examples should ideally cover edge cases that you might reasonably encounter. So one of these might be the standard case is tell me about the 2020 California wildfires. And we'll tell the LLM that if it decides to use the RAG tool, it should structure the query like this, and it should give a date range like this. And then another question might be, what happened during the presidential election? And the response that we desire is, please ask for a date range because the news spans several decades. It could be one of many presidential elections. Please specify which one. So there are probably more edge cases than can be covered, but I thought that this was the basic minimum requirement to get it working reliably. And finally, just some little instructions to clean up the LLM output as much as possible. Do not include any text before or after the specified format. Do not waste your time on explanation. Do not include markdown bullet points, numbered lists, etc. So once that's done, we can initialize the agent with this while loop, and then we can talk to it with our amazing UI. It's called a terminal. I'm not a UI guy, I'm an ML guy. I know nothing about your HTMLs and your Node.js's. But anyway, let's just ask a simple question. What was the humanitarian response to the 2020 California wildfires? So you see that the agent invokes the RAG search tool and it asks a little query like this, and it gives a date range exactly as we expect. And these are the top 3 search results. So if you were to look at the dates, you see that they are all constrained to the approved range. And the content is indeed relevant. It's about firefighters, the American Red Cross, GoFundMe, federal disaster relief, etc., etc. So the final answer encompasses the information that we were looking for. So that's pretty good. So the obvious question now is, how is this meaningfully different from RAG? So that actually leads me to a discussion about something that the team at Elastic is calling intelligent hybrid search. Let me find my slides. Yeah, okay. So the idea behind intelligent hybrid search is that when you reach a certain scale, being able to constrain your search surface becomes important. What that means is, if I have, say, 2.3 million documents in my vector DB, I am probably never going to ask a question that sincerely requires analysis or consideration of 2.3 million articles. In most cases, it's probably going to be like 20 or 30 articles at most. So there is a question, why should you waste computational power on things like vector similarity calculations when maybe you can trim away a large number of articles to begin with, and then focus your computing power on a smaller set of articles that are more likely to be relevant? So the way that you achieve this is by making use of metadata that is inherent to the data set. So for example, that will be your timestamps, your geographical locations, your extracted entities, your categories, and an unlimited number of other metadata fields that you could think of. When you've extracted all of these, you can do something that we call intelligent hybrid search. So let's say that I've got this big news data set, 2.3 million documents, and I ask a query, hurricane in Gulf of Mexico 2012. Okay, I could do a naive vector search with no optimizations, and that will basically do 2.34 million similarity calculations, and it will take a long time. That's not ideal because I know that the time taken to do that vector search is going to grow linearly with my data. So on the flip side, I can recognize that a very small portion of those articles are likely to be about this hurricane I'm asking for. So one thing I can do is filter by date. Okay, you said 2012, fine. Only articles from 2012. And that cuts, let's say, it cuts the 2 million articles down to about 10,000. Then from that set of 10,000, we further filter down with a keyword match, maybe looking for weather, looking for hurricanes, looking for news about the Gulf of Mexico, whatever. And the 10,000 articles become 4,000. And then we do the vector search on those 4,000. And the upside, two interesting things have happened. First of all, I very likely have just substantially increased my search relevance because I've cut out a lot of irrelevant noise from consideration. Second thing is the timing of a given search is probably going to increase very slowly because how many, like my data set may grow, but how many articles am I going to add on about a particular topic like this, hurricanes in the Gulf of Mexico? Probably not that many. So I would expect my timing for a given search to grow less than linearly. I wouldn't make any strong claims about this, but I'd say pretty confident it would be less than linear. So pretty strong advantage. So my personal thinking is that intelligent hybrid search is going to be really important for scaling really large search use cases in the future. But the question then has to be asked, how are you going to achieve this in practice? So let's look at intelligent hybrid search. Well, first, we're going to look at hybrid search. Let's have this question from my big news data set, Japan greenhouse gas emissions pledge after 2020. Okay, let's just do a hybrid search, which is text search and then semantic search. And the results are all for the wrong dates and they're not particularly relevant. Only one of these articles is about Japan. I see G8 here. I see some climate action tracker. Okay, not relevant. Let's go to intelligent hybrid search. So here we are constraining the search surface. We are saying articles published after the 1st of January 2020. And we are constraining the article categories to climate, environment, sustainability, weather, geographic location, Japan. And then we do our semantic search. And you can kind of see how the constraining of the search surface can be done with cues taken from the query. Japan greenhouse gas emissions pledge after 2020. So the results here are pretty much ideal. If I pass these search results to a large language model, it would generate the correct answer. It wouldn't have done that with this hybrid search. So I think that's pretty cool. But then the question comes, how do you achieve this in practice? And the first response might be, okay, let's do some pretty sophisticated prompt engineering. Let's pass in data schemas, example queries, valid inputs, guidelines, etc. Put that all into a large language model and get it to generate a query. There's an immediate problem with this. First of all, speed. You are now going to put in a pretty huge and extensive context into your LLM, and you're going to get it to spit out a large query, and that's going to take quite a lot of time. It's going to mean that you'll have to wait maybe upwards of 8 to 10 seconds to get an answer from your search engine, and that's not something that we want to countenance in production. Second thing is that the generated query is likely to be well, I wouldn't say likely to be hallucinated, but you've got a pretty good chance of it being hallucinated unless you're very careful. So the advantage of using the agent was that we didn't rely on the LLM to generate the query. We pre-specified the query format and then just got the LLM to spit out the specific inputs. So we don't run into the problem of the query being malformed. Not really. And so we can be sort of reasonably confident that implementing this with an agent, this intelligent hybrid search idea, is going to be more reliable and sustainable in the long term than getting the LLM to spit out a query. So I think that's pretty cool. Let me see. Is this slide useful at all? No, it's not super relevant right now. So I didn't cover the intelligent hybrid search idea in this blog exactly. This stays a basic tutorial on how to set up Agentic RAG, but I am writing something specifically for this intelligent hybrid search idea. So please keep an eye out for this on Elasticsearch Labs. Uh, Full content and code examples are here. And if this is useful to you, I highly encourage you to check out the other material that my colleagues at Elastic have written. There really is just a massive wealth of knowledge on how to make you full use of Elastic to do the thing it does best, which is search and security and observability. But this is the Search Labs blog, eh? So yeah, I think that's about it for me. See you guys.